Hello there viewers. So today I would like to explore some of the exam favorite questions, and it's not that difficult, but people, if they don't understand it, they're going to lose some marks. Alright. So you may heard of this type of relations before in your high school days, and today we're going to explore about this many to one, because it's like one to one. It's still a function, but it has no inverse. Okay, so today I would like to explore what does it mean by many to one function, but has no inverse. Alright, so let's have a look. Okay, so this is a normal quadratic and modulus and a quadratic graph. If you have a look here, it's a many to one. It's many to one. Alright, it's a many to one graph. And if let me ask you, can you draw the inverse of that? Draw the graph inverse. Okay, if you have learned from our flip method just now in the previous videos, you might be able to get yourself this one. Okay. So this is the fx, and this is the inverse, this is the fx, and this is the inverse. Now, if you have a look on the inverse, if I do the vertical line test, okay, if I do the vertical line test, let me draw a bit. Draw a bit here, so sorry. So VLT, I have two intersects here. Same goes for here. If I do a VLT, a vertical line test, I have two intersections here. If there's a two intersection, that means it's not a function. So basically you're saying that our many to one function has turned into one to many function. Alright, so I can say that f inverse x is one to many, so f inverse x is not a function. So over here I can state as well that fx has no inverse. Alright, fx, so the original function. So that's what happened. But the exam question might be a bit different. The exam favorite questions is something like this. They give you, let's say, fx at modulus x plus 2. It's a many to one function, and the question going to ask for it, what is the domain for it to either has an inverse or be one to one function. Technically it's the same question. Alright, just a different way of saying the same. Oh my god, the same question. Yeah, you get the idea. Right, so if you draw this graph, so I'm going to ask you, where is the axis of symmetry? The axis of symmetry is this one, where I can say at x equals to 0. Okay, because if you try to fold it, then that's the symmetrical. So I'm going to split it at x equals to 0. I'm going to get two graphs. Okay, one here and the one on the right side. And this one here now become one to one function. If you do vertical line test, it's a 1. So you do VLT, vertical line test, it only touch only at one place. Now, if it's a one to one function, now it has an inverse which looks something like this. Okay, this is the inverse for that, this is the inverse for that. Remember to draw the y equals to x as well. So back to the question when it said what is the domain for fx, to has an inverse or either to be one to one function. So the domain is this one, infinity until 0, 0 until infinity, which for this case as well, 0 is included in the equation, because, and you need to do this way, please write or not union. I know union means for everything, okay, but you're trying to split. It's one case of this side, another case of this side. So technically speaking, if you see this type of function and you realize there's an axis of symmetry, so you need to split it for this graph, for this function to has a one to one function or inverse. Okay, that's the formal way of doing things. And another way of doing it as well, the same type of question, or this is the algebraic, you may have a little look. So this is how you do it. Okay, so for inverse, for the modulus, you move around, you find the inverse, and then you see there's a plus minus sign. Okay, so this one works for x less than 0, x less or equals to 0. This one works for x more or equals to 0. But let's say if you just want to find the domain, you don't need to do all of this. Just from the graph, you'll be able to find the answers, and that's enough. This is just a formal working steps for those who are curious on how we can get this kind of graph. Okay? The same can be said for the x squared, for the quadratic graph. Okay, right? the questions are still the same. What is the domain for fx to has an inverse or for it to be one-to-one function? It's the same type of question, just a different way of saying. And then, so this is the x squared graph. So where's the axis of symmetry? The axis of symmetry is over here, where x equals to 0. You can see where, if you fold it in half, then you got the same things. So now we split them up into two parts, over here and over here. And then we can draw the inverse graph, over here and over here. Okay? So the domain for it to has an inverse, or for it to be one-to-one function, is the same. Negative infinity until 0, or 0 until infinity. Okay, I know some of you might ask, Sir, how can we have a square root graph here? This looks very dodgy. Alright, so never mind, I'll show you the calculation. Here's the formal working steps, for if you want to have a look. Well, the point is, at here when I have x squared equals to y minus 2, you can pause the video for you to have a look overall. But the idea is when there's x squared, so when I square root it, when I move the square, there's a plus minus sign. Because there's a minus sign, so that's why we have learned this before. When there's a minus outside of a square root, so the graph goes out there, down there. Okay, it's flipped down. Alright, so that's why you can have this, that's why you can have that. So the answer for this type of question, what is the domain for it to has one-to-one inverse? This is the answer. Alright, you do not need to do all this calculation if you just want to find this one. You just need to draw the graph and you'll be fine. So these are just the formal way of doing things. Okay, alright, that's all. So thank you for watching. Like I mentioned before, this is not that difficult. It's still doable. I hope that you just learn how to get it. Because in exams, let's say it's a 13 marks questions, this will be the last 5 marks, most likely. So like I mentioned before, it's not that difficult. You just need to understand it. Okay, thank you for watching. Please comment, share, like and subscribe. And if you have any questions, just drop your comment down below and I'll try to answer them for you. Alright, if you have any of your friends who do not know how to answer this type of question, which it's not that difficult, just pass this video to them and hopefully they'll be fine. Alright, thank you for watching. Bye.